Lift off and the clock has started.
Godspeed, John Glenn. We have you go for orbit here. Go for orbit.
That's one small step for man.
Doing tricks and stunts and flips and rolls that weren't possible here on Earth.
We have ignition and liftoff of Columbia.
Main gear touchdown.
Space Camp Florida, where the past meets the future, and youngsters live their dream today. Here is where the pioneering efforts demonstrated by the founders of the United States Space Program guide campers through a 5-day adventure that takes them to the stars. The giant space station habitat is the campers' home away from home during their visit. Mealtimes are spent at the Milky Way Cafe. The United States Astronaut Hall of Fame, next to Space Camp, provides trainees with an insight into the history of the space program and the brave men who launched the nation into the space age. More than 30 years ago, 7 test pilots were named by NASA to fly in the Mercury program. For a short time, they tumbled in a trainer called the Multiple Axis Space Test Inertia Facility, or MASTIF.
Hi, my name is Jason. I am 13 years old and I am from Inverness, Florida. The reason I'm at Space Camp is because I want to be an astronaut when I get older. You're about to see our ride on the Multi-Axis, a simulator that was used during the Mercury program.
Aren't you not supposed to be in there? my name is Nick Titus, and I'm 10 years old. I'm from Utah, and the best part of the Maldi axle was seeing yourself being thrown forward and spinning. You feel like a yo-yo. The reason I'm at Space Camp is because it was a birthday present from my parents.
Even as astronauts continue to fly in their tiny one-man Mercury capsules, President John Kennedy issued a startling challenge that began the greatest adventure mankind has ever undertaken.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
The name of the project was Apollo, a massive technological undertaking involving hundreds of the brightest minds in the country. Before Apollo could be launched, however, much had to be done. The two-man Gemini program helped test the hardware and techniques needed to go to the moon. During Gemini, astronaut Ed White performed the program's first extravehicular activity, or EVA. He trained for America's first spacewalk on a NASA trainer similar to the 5 Degrees of Freedom at Space Camp.
Hi, my name is Michael Blissett, and I'm 12 years old, and I'm from Romeoville, Illinois. And the reason I'm at Space Camp is it was a birthday present from my mom and dad. You're about to see the 5 Degrees of Freedom, which are side to side, forward and backward, yaw, pitch, and roll.
Whoa, good God! No, upside down. Help me. Hello, people. Whoa. Oh, wow.
Next we have Mitch.
Here comes the fun part. Beaver upside down. Yeah.
Next we have pitch. And roll. Next we have pitch. Roll.
Hi, my name is Grant Cooper. I'm 12 years old and I'm from Ames, Iowa. My favorite part of the 5DF was the roll. The reason I'm at Space Camp is that it was a birthday present from my parents.
During Gemini, astronaut Buzz Aldrin developed training techniques underwater to assist spacewalkers. Underwater training that is still used by astronauts today. During the summer, campers travel to a nearby pool to experience the same kind of near-weightless feeling. They learn that performing simple tasks isn't so easy in the zero gravity of space. By studying the past, trainees see how far the space program has come. The food eaten by the earliest space travelers is sampled during a meal, and suits worn by space pioneers are shown to campers in a demonstration of how far astronaut protection has evolved. It was the bulkiness of the huge Apollo spacesuit, with its many protective layers and awkward life support system, that prompted NASA to develop and simulate techniques for astronauts to walk and work on the surface of the moon. Space Camp's 1/6 chair is similar to one used by the Apollo crews in training.
Hi, my name is Scott Hansen. I'm 12 years old, and I'm from Millbank, South Dakota. The reason I'm at Space Camp is I would like to become an astronaut when I grow up. Our rides on the 1/6 gravity chair are next. The three basic steps on this chair are the bunny hop, the side-to-side step, and the astronaut jog.
Hi, my name is Joe Cosman, and I'm 11 years old, and I'm from Blue Island, Illinois. The best part of this 1/6 chair was the hopping. The reason I'm at space camp is because I thought this would be my first step to becoming an astronaut.
By the end of Apollo, NASA had set its sights on establishing a permanent presence in outer space. In the 1970s, for weeks and months at a time, American astronauts lived on an orbiting space laboratory called Skylab. In an effort to combat the debilitating physical effects of extended weightlessness, Skylab astronauts exercised in circumstances similar to using the space station mobility trainer.
Hi, my name is Josie. I'm 11 years old, and I'm from Cocoa, Florida. The reason I'm at space camp is because I won a scholarship. You're about to see our turns on the SSMT, which is similar to how astronauts trained on Skylab.
Small steps, push really hard.
My name is Corey. I'm 11 years old, and I'm from Cape May Courthouse, New Jersey. The best part of the SSMT was spinning around really, really fast. And the reason I'm at Space Camp is because it was a birthday present from my mom.
More than 250 scientific investigations were performed by Skylab's 3 visiting crews. Trainees undertake some investigations of their own in a space lab, equipped with a series of experiments designed to test their knowledge and capabilities regarding a variety of subjects, including weather, solar activity, and vacuums. Other scientific phenomena are explored during a demonstration of strange science. Scientific demonstrations and a close-up look at the planets these campers hope one day to explore are seen during a visit to Florida's largest planetarium at nearby Brevard Community College. The concept of trajectory and how spacecraft can reach those faraway planets is demonstrated to campers on a trajectory chair. Rockets that have been used throughout the years are on display at nearby Kennedy Space Center. During their tour of the center, campers get an up-close look at space history. Here, rockets ranging from the earliest Redstone to the giant Saturn V that took man to the moon to today's Space Shuttle orbiter are on display. Building their own model rockets gives lessons in propulsion and aerodynamics, concepts that are demonstrated when those rockets are launched.
5, 4, 3, 2, 1. It's gone! My rocket's alive! Oh, cool. It's gone to the 5, 4, 3, 2, 1.
Not only do campers learn where we've been, they get a glimpse of where we're going. A zero-gravity wall allows trainees the chance to build in space, much like astronauts will when constructing the International Space Station. Based on a space shuttle experiment called Access, a series of weights and pulleys help simulate the weightlessness that will be felt by space station construction crews. Extended stays in an orbiting space station create the need for a new way of producing food supplies. Lessons in hydroponics show campers how food can be grown without using a lot of space and resources. Mars. It's the next logical step on our journey to the stars. After learning more about our closest planetary neighbor, campers establish their own base on the red planet. They then explore their newly created colony in the Mars rover. One day, it's believed, space travel will be routine. The concept of a reusable space plane that can travel into orbit and safely return its crew back to Earth became today's space shuttle.
10, 9, 8, 7, we have a go for main engine start. 5, 4, 3, 2, 1, and liftoff. Liftoff of the Space Shuttle Columbia, catapulting scientific knowledge through microgravity research.
We're in the row, Houston.
NASA's Space Transportation System is actually made up of 3 parts. Twin rocket boosters that are jettisoned shortly after liftoff once their solid fuel has been expended. These are reusable and are picked up in the Atlantic Ocean and towed back to Kennedy Space Center for refurbishing. About 6 minutes after the SRBs separate, the external fuel tank is jettisoned, following cutoff of the main engines. The tank breaks up as it re-enters the Earth's atmosphere and is the only part of the system that isn't reusable. The orbiter is about the size of a medium-range airliner, 122 feet long with a wingspan of 78 feet. The rocket motors in its tail are used only once for the trip into space. Coming home, the orbiter acts like a glider, the heaviest glider ever built at 98 tons. Helping the orbiter, and more importantly its crew, withstand the tremendous temperature variations of space travel, NASA created special tiles and blankets that are meticulously assembled on the surface of the spacecraft. These silica-based tiles are able to withstand temperatures that climb to 2,700 degrees at re-entry and must remain intact throughout the mission to ensure a crew's safe return. During the trainee's stay, emphasis is put on qualities like teamwork and cooperation, key elements of the camper's simulated space shuttle mission. By working together in both mission control and in the orbiter, campers take an out-of-this-world journey.
Hi, my name is Colin Liston. I'm 11 years old, and I'm from Livonia, Michigan. The reason I'm at Space Camp is because I want to learn more about space. During the Endeavour mission, I was the payload specialist, and my job was to do chemical reaction experiments.
All positions stand by to resume the countdown on my mark. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Mark. Endeavour. T-minus 2 minutes and counting. Retracting crew access arm. T-minus 1 minute and counting. All tracking stations reporting good signals.
Checking ET pressure.
T-minus 31 seconds and counting.
Roger. Auto sequencer start.
T-minus 20 seconds. Arming sound suppression system.
Ignition systems are armed.
T-minus 10 seconds. 7 main engine start. 3, 2 booster ignition and liftoff.
Roger, liftoff. Engines at 104%.
Endeavour, you have cleared the tower.
Begin roll program.
APUs running normal.
The 120-degree roll program complete.
Endeavor, now 1 mile high velocity, 950 feet per second. Velocity at 1,400 feet per second. Altitude is 4 nautical miles. Downrange 0.5 nautical miles. Endeavor's altitude is 22 nautical miles. 14 miles downrange. Velocity 3,400 feet per second.
Endeavor, stand by for booster burnout and automatic separation in 30 seconds.
Roger, Endeavor. Confirm SRB set.
With this report of negative return means the orbiter is no longer capable of a return to the launch site aboard to Kennedy Space Center.
Endeavor, press to MECO, cut off in 90 seconds.
Recovery ships confirm that the SRBs have parachuted about 141 nautical miles off the coast into the Atlantic Ocean in good shape. Recovery is now underway.
Endeavor, throttle down.
Stand by for MECO.
We have a warning.
Warning.
This drop tank is not separated.
Flight director, Ida.
Hurry.
Endeavor, we confirm ET set. Roger, Endeavor, you are go for initial orbit ops 104.
Endeavor, you are go to shut down fuel cell 3 to conserve power.
Roger. Full shutdown of fuel cell 3 to conserve powers. I will also shut down APUs 2 and 3.
Endeavor, you are go for nominal ohms to burn.
Watch mine. Okay. We confirm a good ohms 2 burn. Ohms 2, Endeavor.
Pilot, please configure main engines for surplus fuel dump. We confirm shutdown, Endeavor. Please perform orbit check. Spec 41.
Roger. IMU orbit check. Spec 41.
Endeavor, your IMUs show a good circular orbit, 165 by 165 nautical miles. Velocity, 17,500 miles per hour. Inclination, 28.5 degrees.
Payload Specialist 2, this is Marshall Payload Operations Control Center. Your go to unstow and begin the crystal growth experiment now.
Roger, Marshall Ops, beginning the crystal growth experiment.
When crystals are formed on Earth, they are badly distorted by various forces, including gravity. In microgravity, these forces are very small. The crystal growth experiment will show that as a result, crystals grown in space take on naturally perfect shape.
Payload Specialist 1, you are go to power up the astronomy telescopes and detectors.
Roger, Houston, powering up telescopes and detectors.
Thank you, Endeavor. We see that the telescopes are powered up. MS2, you are going to begin your first set of astronomical observations. Space telescopes are much more effective than Earth-bound telescopes. On Earth, their view is badly distorted by the atmosphere, pollution, and bright lights.
The cosmic ray detector is counting the high-energy particles emitted by the stars when they explode. The gamma ray detector will give us new information about quasars and centers of active galaxies.
Mission Specialist, you are going to begin the biomedical experiment.
Request permission to begin on-orbit and payload ops.
Affirmative, Endeavor. You are go for Ops 201.
Roger, entering and executing Ops 201 in flight computer. Go quickly.
Houston, I'm powering down APU number 1.
Talking to the mic and tell us.
Quicker, guys.
Payload Specialist 3, you are go to prepare the material science labs for operation.
Skip it.
Thank you, Endeavor. MSL-1 will allow you to make special types of glass that cannot be made on Earth. In microgravity, sound waves are used to suspend the glass in furnace so it will not touch the container walls. Please power up the crystal furnace lab.
Recopy, Marshall Ops. Powering up the crystal furnace lab.
Endeavor, you are go to start data transmission. Thank you, Endeavor. The crystal furnace can process many samples at once and will reach the temperatures of nearly 2,000 degrees. The growth of perfectly formed crystals could lead to the development of better medicines and advanced microchips.
Endeavor, Marshall Ops here. Please power up the pallet and mid-deck experiments. Endeavor, please activate the Getaway Specials. The Getaway Specials contain experiments designed by private individuals and companies. The experiments are then placed in special containers to be taken into microgravity aboard their orbiter.
Houston, we think we have drifted a bit. Can you confirm that and advise?
We confirm you have slipped a little. Please enter course coordinate spec 53.
We copy, Houston. Spec 43 for course correction. Thank you.
Payload Specialist 2, have you completed the crystal growth experiment?
Roger, Marshall. The crystal growth experiment has been cleaned up and stowed.
Mission Specialist 2, have you completed your first astronomical observation? Endeavor, you are passing from the night side of the Earth. Please stand by to begin the solar experiments. I am powering up the data recorders. We copy, Endeavor. Now power up the telescopes.
Roger. Switching telescope power on.
Endeavor, we confirm the telescopes are up and running. You may power up the monitors.
We copy. Monitors are on and all solar experiments are running smoothly. Data is being relayed now.
Thank you, Endeavor. We are receiving a good data downlink. The solar experiments are showing information about the origin of sunspots and solar flares. Flares are dangerous to astronauts on EVA. Endeavor, prepare to start the mapping radar.
Endeavor, first we would like you to power down the crystal furnace and power up the magnetic levitator. We see the MSL-3 starting up now. Payload Specialist 3, you may now begin the second biomedical reading.
The magnetic levitator works like the acoustic levitator, but uses special magnets to keep the sample from touching the container walls.
Endeavor, you are going to start the mapping radar.
Roger. Powering up the mapping radar and switching on the pointing control system.
Endeavor, we see the radar powered up and the recorders are still running. Start downlink transmissions when ready.
This is Endeavor. We are transmitting now.
Endeavor, you are once again passing into the night side. Flight director requesting permission to perform a 90-degree pitch maneuver in order to point astronomy instruments at deep space.
Houston, altitude maneuver complete.
Mission Specialist 2, the orbiter is in the proper configuration for you to begin your second observation. You may proceed at this time. Endeavor, you are going to power down the solar experiments. I am turning off the data recorder.
Roger, powering down the solar experiments.
Endeavor, we would like to start up the latex reaction experiment.
Endeavor, Houston, it's time to come home. Begin deboard preparations.
Endeavor, Marshal Ops here. Stand by to begin the shutdown procedures.
Marshal Ops, this is PS2 standing by.
Payload Specialist 2, power down the mapping radar transmitter, pointing control, and then the mapping radar power.
Payload Specialist 2, you are go to power down the magnetic levitator.
Roger, I am powering down MSL-3.
Payload Specialist 2, please power down the latex reactor, then the materials science lab and the acoustic levitator.
Roger, Marshal Ops. I am shutting off the latex reactor, materials science lab, and acoustic levitator power and data.
Mission Specialist 1, have you completed the biomedical experiment?
Josie.
MS1.
Josie. No, she is not. Roger, Marshal. The chemical reaction experiment was a success, and it has been powered down.
Payload Specialist 1, have you completed the chemical reaction experiment?
Roger, Marshal. The chemical reaction experiment was a success, and it has been powered down.
Endeavor, Marshall. We confirm shutdowns of all experiments. You are go to shut down the power systems.
Roger, shutting off power systems. All is stowed and cleaned up on the mid-deck. We are ready for deorbit.
Houston, Marshall here. All pallets and mid-deck experiments are powered down and secured. We are ready for re-entry.
We copy that. Prepare for deorbit.
Endeavor, please configure power systems for re-entry. Confirm that fuel cells 1 and 2 are operating. Then pre-start fuel cell 3.
Roger, fuel cell 1 and 2 are go, and I am powering up fuel cell 3 cryo tank.
At the rectum.
Endeavor, you are go to bring all GPCs online in order.
Roger, flight. I'm powering up all 5 computers.
And you are go for full start of fuel cell 3 and ESS buses A and B.
Flight director.
Endeavor, we confirm all GPCs are up and running. Please continue power-up procedures.
Roger, Houston. The GPCs are running and all crossfeeds are go. I will now check the IMUs to see if we are in proper procedure for re-entry.
Endeavor, you are go to start up APU number 1.
Roger, go for APU 1 startup.
Endeavor, you are in position for a good re-entry, but you need to reorient your attitude. Please pitch the nose down 90 degrees to point the tail into your direct of motion. So the ohms 3 burn will slow down the vehicle.
Roger, Houston. Pitching nose down 90 degrees.
Confirm APU number 1 at full speed.
Roger, Houston. Closing doors and turning off floodlights.
Mission Specialist 2, have you completed your second set of observations?
Flight, all equipment is stowed. The payloads have been secured and everything looks good for re-entry.
Endeavor, this is the commander. All crew members return to your seats and prepare for deorbit. Please report all status at each position. Mission Specialist, Josie.
Mission Specialist 1 is go.
Go. Payload Specialist. Payload Specialist 1 is ready.
Payload Specialist 2 is go.
Pilot reports all systems are configured for deorbit.
Houston, Endeavor here. All crew members report they are in position and standing by for re-entry.
Thank you, Endeavor. You are go to enter Ops 301.
Roger, entering Ops 302 into the flight computer.
Endeavor, we see you on track for a nominal re-entry.
Endeavor will soon reach entry interface. The orbiter is traveling at nearly Mach 25. As soon as it hits the atmosphere, it ionizes the air molecules into plasma, which block out all radio waves. During interface, the orbiter can use an antenna to communicate through TDRS.
Endeavor, Houston Mission Control Center. Interface and initiation in 10 seconds.
Entry interface ignition.
Affirmative.
Flight Director, GCO. I'm scrambling the chase plans and starting the tracking cameras.
Endeavor, prepare for landing approach information.
Thank you, Houston. Standing by for weather advisory.
Endeavor, please set data for the body flap.
Edwards report the sonic boom has been heard and visual contact is verified.
Endeavor, you are now at 18,000 feet. Velocity 732 miles per hour.
Endeavor, you are approaching the heading alignment cylinder on course for waypoint 1. Prepare for auto land interface. Spec 86.
2 miles out, 370 miles per hour at 7,500 feet.
Full flare.
10 feet, 8 feet, 7, 6, 5, 4.
Touchdown.
Touchdown, main gear.
Confirm main gear touchdown. Houston, Endeavor, we're home!
Roger, Endeavor, we copy you.
Yay.
Down and stopped, configured for convoy.
Hi, my name is Colin Liston. I'm 11 years old and I'm from Livonia, Michigan. The reason I'm at space camp is because I want to learn more about space. During the Endeavour mission, I was the payload specialist, and my job was to do chemical reaction experiments.
To demonstrate that a shuttle mission is the best example of teamwork, trainees switch places for their second mission, so they get the opportunity to be both astronaut and ground support. By the time their adventure is over, these youngsters have learned about all the hard work that's behind the accomplishments of the men and women involved in America's space program. They see that their future in space can happen. All it takes is a lot of hard work, perseverance, and the dream that will carry them to the stars.
Hi, I'm Leslie Nyhouse, manager of Space Camp Florida. I wanted to thank you for the opportunity to work with your children this week. It's been a great week. We've really had a wonderful time learning and sharing with each other. These children have got the talent and enthusiasm to go anywhere they want to go. If they want to go back to the moon, if they want to be the first to set foot on Mars, if they want to work on the space station, we think they've got what it takes to make that happen. And again, we've been proud to be a part of that process and wish them all the best in reaching for the stars.
Good morning, my name is Chris Lamarada, and I had the pleasure of working with the Sun team this week. First, from Romeoville, Illinois, as Payload EVA Officer and Payload Specialist, Mike Blissett. From Ames, Iowa, as Commander and Principal Investigator, Grant Cooper. From Millbank, South Dakota, as Pilot and Ground Control Officer, Scott Hansen. From Blue Island, Illinois, as Instrumentation and Communications Officer and Pilot, Joe Cosman. From Livonia, Michigan, as Payload Specialist and Instrumentation and Communications Officer, Colin Liston. From Cocoa, Florida, as Mission Specialist and Flight Director, Josie Smith. From Guatemala City, Guatemala, as Commander, Mission Scientist and Principal Investigator, Carlos Torrillo. From Ypsilanti, Michigan, as Mission Specialist, Mission Scientist, Kevin Trombley. From Inverness, Florida, as Flight Director and Payload Specialist, Jason Varquette. From Cape May Courthouse, New Jersey, as Payload Specialist and Ground Control Officer, Corey Weinberger. And last but not least, from Park City, Utah, as Mission Specialist and Payload EVA Officer, Nick Titus. Thank you, Sun Team, for a wonderful week.
Our other activity are the 2 simulated space shuttle missions. Each team learns how to work as a group together as if they were launching a shuttle. Half of the team goes into mission control and becomes the ground crew. The other half goes into one of our simulated flight orbiters, one that you see behind me, and they become the flight crew. Then for the second mission, they trade places. Those in the orbiter become the ground crew in mission control. Those in mission control become the flight crew in the orbiter. This way, each camper gets to experience all aspects of a shuttle mission. And this week, our newest flight crew is the Sun team. The Sun team received 193 points out of a possible 200 on their missions.
The Outstanding Camper Award for this week goes to a member of the Sun team, Jason Varquette. Jason's team leader writes, Jason was a wonderful addition to the Sun team this week. He was always a leader, whether at work or at play. His constant energy and enthusiasm were contagious. His thirst for knowledge inspired many intelligent questions. I have no doubt that we will see Jason as a shuttle crew member in the future. Congratulations.